Right, good evening and welcome to mathsatoka online class. In today's video, we'll continue with from where we stopped in our previous video on wave. Okay, if today is your first day of watching, please consider subscribing. And if you have been watching without subscribing, please just click on the subscribe button. It is free, and then click on the notification bell so that anytime we drop a video, YouTube will notify you on that. Okay. Now, the general equation of wave is given by, you know that if you look at this is a sine graph. So we use sine. So we say that y is equal to what? Y is equal to sine theta minus phi. Okay? Sine theta, don't forget your amplitude. A sine theta minus phi. And we call that what? That theta is equal to what? The phase angle. The phase angle. Okay? And then phi is what? The phase difference. The phase difference. Okay. So since we have this, then and don't forget that, so let me continue here, that y is equal to a sine theta minus what? Minus phi. Okay, now this is what? Y is equal to a sine, don't forget that what? Theta is equal to omega t, because omega is equal to what? Angular displacement over time. So angular displacement, or the phase angle, is known as what? Omega t. So we have that omega t minus, this is kx. Okay, this is kx. So what do we have now? We are having that that our w, don't forget that w is equal to what? 2 pi f. Okay, our w is equal to 2 pi f. Please note that w is equal to 2 pi f. Yk is equal to what? 2 pi over lambda. 2 pi over lambda. So if we substitute this, we are going to have that y is equal to a sine, inside here I'm going to have 2 pi ft, okay, minus what? 2 pi over lambda, 2 pi x over lambda. Okay, so from here we are going to have that, but we know that v is equal to what? F lambda. V is equal to f lambda. Don't forget this formula. V is equal to f lambda. So if we make lambda subject of the formula, lambda itself will now be what? This one will go here to have v over f, is it not? But what I'm having this side is 1 over lambda. So if I turn this one, I'm going to turn this one. So 1 over lambda that I have here is then as what? F over what? Over v. Okay, so in fact these two formulas are the most important formulas, this 1 and 2. Okay, then if you want to go further, you can start going further, but these are the two major important formula you need to know. Or if you just know this formula, you will now know that w is equal to what? 2 pi f, and then k is equal to what? 2 pi over lambda. If you just know these two, you are okay. But let's just go further. We're having that y is equal to a sine, in bracket of what? 2 pi ft minus, don't forget that 1 over lambda gave us 2 pi what? F over what? Over v. F over v, right? F over vx. Because 1 over lambda gave us f over v. So if we factorize, we're going to have that y is equal to what? A sine, if you bring out 2 pi f, that is here, in bracket of what? T minus what? T minus x over v. Okay, so this is equation 3. These are the 3 main equations that you need to know. And then don't forget that we can use plus here or minus. When do we use minus? We use minus when the wave is in the positive x. Please, we use minus when the wave is in the positive, in fact the right hand side, the positive x, we use minus. But if it's in the negative x, we use plus. Okay, so let us solve some questions to help us clarify some things. Okay, so what do we have now? Let's solve some questions. So the first question said, a plane, now sometimes they switch it. It depends on what you are seeing in the equation given. Okay, sometimes they will write this one first before this one, or this one before this one. So it depends on what you are seeing in your own equation. So look at this. They say that a plane progressive wave is represented by the equation. Is represented by the equation y is equal to 2 sine 2000 pi t minus 0.5x. Okay, that's what they gave us. They say where y and x are in cm, where y and x are in cm, comma, t in seconds, and the pi is given as 3.14. Okay, these are the things they gave us. So what do we do in this situation? Solution is very, very simple. Solution, what do? They gave you that y is equal to what? 2 sine 2000 pi t, okay, minus what? 0.5x. Okay, so by comparison, let us compare the one we know. The one we know is that y is equal to what? 2 sine wt, okay, 2 pi wt minus what? Kx. So this is the one that we know. Now comparing from this one that we already know, it can show that what? Sorry, a, this is a, not 2, a. Okay, from this one, you know, you can see that automatically our a is what? 2. Okay, and then our wt is equal to what? 2000 pi t. Okay, sorry, what did they say we should calculate? Sorry, calculate the frequency. They say calculate the frequency, calculate the wavelength, which is lambda, and then calculate the speed. Okay, so these are the things we are asked to calculate, but I know that w is equal to 2 pi f. Okay, 2 pi f. So if we now do this, we see that t will take care of t, which shows that our w, okay, which shows that what? That w is equal to what? 2000 pi. But we know that w is equal to what? 2 pi ft. 2 pi f, sorry. 2 pi f is equal to what? 2000 pi. So pi taking care of pi, we are seeing that 2f is equal to 2000. So we show that our f is equal to what? 2000 divided by 2. So our f is equal to what? 1000. We have gotten our f. Okay, so the next thing we need to get is the lambda. Okay, but we by comparison here, we can see that kx minus kx is equal to what? Minus 0.5x. So minus take care of minus, x take care of x. So I'm having that my k is equal to what? 0.5. So if my k is equal to 0.5, then we know normally that k is what? 2 pi over lambda. Okay, 2 pi over lambda, which they say is equal to what? 0.5. So what do we have now? If I cross multiply, I'm going to have that, let me continue solving from here. I'm going to have that lambda will now be what? 2 pi over what? 0.5. So my lambda is equal to what? 2 times 3.14 divided by 0.5. So I'm having that my lambda is 12.56 in cm. Okay, so the next thing they say we should calculate is the speed. We know that v is equal to f lambda. So my v now will now be what? 1000 times that 12.56, which will give you that v is equal to what? 12560 cm per sec. Okay, cm per second. So but we can change it to meter per second. I hope you know that we can change it to meter per second. That is changing the cm to meter before multiplying. So that is that. So what do we have? Okay, so that is that. Very simple question. So let's get to another question so that we can understand better. So number two says that okay. Number 2 says that we have that the equation of a certain progressive transverse wave okay, is y is equal to 2 sine 2 pi in bracket of what? T over 0.1, okay, 0.01, okay, minus x over what? 30. Okay, we have this. So the now said we should, where x and y are in cm and t is in second, calculate the period of the wave. Calculate the period of the wave. Calculate the what? Period of the wave. Okay, now if you cannot remember any other formula, okay, if you cannot remember any other formula, what you have to do is what? Don't allow anything to be at the back here. Okay, don't allow anything to be at the back here. All we know, just know that y is equal to what? A sine what? Wt minus what? Kx. Don't forget this one. This one is okay. Then from here you will have that y is equal to a sine, okay, my w is what? 2 pi f. So 2 pi ft minus my k is what? 2 pi over lambda x. Is it not? Now if you bring out the 2 pi that they brought out, you have that what? Y is equal to a sine 2 pi that they brought out. I'm having that what? Ft minus what? Minus x over lambda. X over what? Lambda. So that is that. Now by comparison, you will see that your amplitude A is equal to 2. And your Ft is equal to what? T over what? 0.01. So if T cancel itself, you are having that what? F, which is equal to what? The frequency is equal to 1 over what? 1 over period, and which they gave me is equal to 1 over 0.01. So which means if you press 1 over this, you get your frequency. But automatically my period is now that 0.01. As simple as that. That is my period. But what they say we should calculate? Oh, the period. The period is 0.01 because f is equal to 1 over this. So let us calculate other things. Though they did not ask for, but let us calculate other things. Calculating other things, I'll have that minus x over 30 is equal to what? Minus x over lambda. This take care of this. So equate these two, equate these two. So therefore my lambda is equal to what? 30 cm. You see, I've gotten my lambda. So for me to get my velocity, I'll have that the speed is equal to what? F lambda. So velocity is equal to what? My f is 1 over 0.01 times 30. So which is what? 30 divided by 0.01. So you get your answer as the velocity. So that is that. You see, this is a very simple calculation. Just by comparison, you get your answer. Just by comparison. So the next one we'll look at is they say that the equation okay, they say the equation y is equal to 5 sine 3x minus 40. Okay, you see what I told you, that sometimes they will write the x first before the t. So do your own the same way they did theirs. Where y is in milliliter, okay, x is in meter, and the t is in seconds. Okay, then represents a wave motion that we should now calculate the frequency I, the frequency II, the period, IV the speed. Okay, so from here we have that what y is equal to what, a sine 3x minus 4t. Okay, so but we know normally, sorry, 5, we know normally that y is equal to what, a sine, since their s came first, I will say kx minus what, the omega t. So by comparison, automatically we will see that our a is equal to what, 5, and our k is equal to what, 3, and our omega is equal to what, 4. So from here we can now calculate our lambda. We know that k is equal to what, k, which is equal to what, 2 pi over lambda, they say is equal to 3. So if I cross multiply, I'll have that my lambda will now be what, 2 pi over 3, which is what, 2 times 3.14, 3.14 divided by 3. So I'm having that my lambda, the wavelength, is going to be, did they say we should calculate the wavelength? Okay, they say we should calculate f, not the wavelength. Okay, but if you do this, you get your wavelength, so the lambda. But calculating f, we know that w is equal to what, 2 pi f. Yes, and our w is 4, so 4 is equal to what, 2 pi f. So my f is now what, 4 divided by 2 pi, which is what, 4 over 2 times 3.14, 142 or 14, anyone. So 4 divided by that, you are going to get that your frequency is now 0.64 hertz. But they say that what, frequency is just 1 over period. So therefore period itself is 1 over frequency, which is what, 1 over 0.64. So which will give you 1.56 in seconds. Okay, so what else did they say we should calculate? Speed is equal to f lambda, and we have gotten our lambda. So when we did this, we got that our lambda is 2.1 meters. Okay, so we know that velocity is equal to what, f lambda, which is what, my f is 0.64 times 2.1, so which will give you the final result. So we have 2 times 3.14 divided by 3, 2.09, which is approximately 2.1. Okay, so if we now have 0.64 times 2.1, so I'm having 12.86, which is 12.9 in meter per second. So that is that. Okay, so let's solve. Do you have any other questions to solve? Sorry, I said 0.64 times 2.1. Okay, sorry, 1.344. That's 1.34. 1.34 meter per second. Okay, so that is that. So the next thing we'll look at is properties of wave. Properties of wave. Properties of wave. Okay, now in properties of wave, we have the first one we have is reflection. The first one we have is reflection. In properties of wave, the first one we have is a reflection. Properties of wave. So in properties of wave, we have reflection. Now, in reflection, when a progressive wave traveling in a particular direction meets an obstacle, it bounces and follows a different direction. Okay, so that is when we call it what? Reflection. Okay, they say that reflection is simply what? The sudden change in the direction of projection of a wave as it strikes the boundary or interface between two medium. Now I have this. Okay, now in reflection it will bounce back. Okay, when light or when wave hits an object like this, okay, then and it then bounce back, we call it reflection. Okay, whenever an object hits what? Whenever a wave hits an object and bounce back, we call it what? Reflection. And then this angle here, this is called the normal. This is the normal. This angle here is called the incident angle, and this one is now what? The reflected angle. Okay, the reflected angle. Now the things you need to know about this is that what? In reflection, the reflected angle is equal to the what? The incident angle. They are all equal. Okay, very important thing to note. They are equal. So this is the boundary. This is the boundary where I is what? The incident angle of incidence. And then R is what? Angle of reflection. Don't forget that I is what? Angle of incidence. Where R is what? Angle of reflection. Okay. So the next thing you need to note is that what? And like I said, the angle of incidence is equal to the angle of what? Reflection. So let's take a question. They say that light is incident on glass. Light is incident on glass at an angle of 58 degrees. Okay, comma. Then I say what is the angle of reflection? Okay, now solution. We know that the incident angle is equal to what? 58, and we say that I is equal to R, so it's equal to what? 58. As simple as that. Okay, so the angle of reflection is simply 68. Okay, so the next one, okay, the next question said, look at this question. It said light ray falls on a surface, okay, and then reflects, comma. It says if the angle between the light ray and the surface is 43 degrees, okay, comma, then I say calculate they say we should calculate. Where is the question? Calculate I, the angle of reflection. The angle of reflection. I calculate the angle between the incident rail and the reflected rail. Calculate the angle between the incident rail and reflected rail. Okay, now if you look at this question, let us draw it to illustrate the question, then we will now get the answer. Now we have this. The light came from here, hit this and then bounce back. But they say that the angle the light made with what, this one is coming like this, don't forget, and this one is going like this. The angle the light make with the surface, with this surface, okay, not with the normal but with the surface, is what, this is a 43 degrees. Okay, now we know that this is the line, the surface and the normal makes an angle of 90 degrees. So to get our incident ray will now be 90 degrees minus the 43 degree, which is what, 47 degrees. So here is what, 47 degrees. And we know that our incident ray is set as the reflected ray, which is what, 47 degrees. So here is equally 47 degrees. So both of them, they now say that is for I. Okay, they say calculate the angle of reflection. So the angle of reflection is what, 47 degrees. Then the angle between the incident ray and the reflected ray is these two angles. Okay, so that is that. The angle between them is simply 47 degrees plus 47 degrees, which will give you 94 degrees. As simple as that. Okay, that is that. So the next one, now let's talk about reflection. We have talked about reflection. Let's talk about what? Refraction. Refraction. Okay, now they say that reflection is the change in the speed and direction of the wave as they cross the boundary between two media of different density. Now the difference between reflection and refraction is that in reflection is that it will hit on that object. Look at reflection here. Reflection said it will hit on this object and then bounce back. Okay, but in reflection, look at what is happening in refraction. In refraction means that it will hit on this object and then pass through that object and go down. Okay, so that is that. Now this angle is called our incident ray, while this one is called our refraction ray. Okay, our refraction ray. Okay, so that is that. Now another thing you need to note is that in reflection, our incident ray is always equal to the what? To the reflection ray. That is I is equal to R here. But in this one is that either I is greater than R sometimes, or R will be greater than I. Okay, depending on how, or let me say I will be less than R. Any of the two. Now if where it is coming from is small, okay, if where it is coming from is small, then it will not be smaller than this. But if where it is coming from is big, it will not be bigger than this. Are you getting it? If the angle of incident is big, okay, in fact, or how do I call it? Okay, let's use density, because we are talking about density. You know that the density of incidence is different from the density of reflection. So if the density of incident is big, okay, let's take something here. There's something they said here, and they said when water wave travels from deep to shallow water, example in a repo tank where the part, okay, where one part is made shallow by placing a glass block below the surface of water, the wavelength of the wave is observed to become shorter in. No, that is not what I wanted. They say when the angle of incident of an angle, when the wave is incidented at an angle to the plane of the boundary of the two media, there must be a change in the direction. Okay, that's not what I am looking for. Look at what I'm looking for here. The medium 2 is less dense than 1, since the direction of the wave is directed blah blah blah. Okay, I just want to show you what happens when okay, now look at what we are saying, that if if the density of the reflected the incident ray is higher than that of refraction, then how do I put it now? It makes, like, watch me now, you know that they changes direction. So if this one come this way, okay, with a smaller angle, then this one will go higher with a bigger angle. That's what I'm trying to say. Okay, when the density here is smaller than this, then this will be what? This will be lesser than this. So that is that. We have that this is glass, for instance, and this is air. Okay, air, and glass is denser, is high, is denser than air. Glass is denser than air. Okay, sorry, if the incident ray has high density than the refraction, okay, then it will now be smaller. We have this when the density of the object of incidence is higher than that of the reflection. Okay, so that is what I wanted to explain. So there are laws that are guiding this. There are laws that are guiding this. In the first one, in the reflection, the first law states that what? That both the incident and what? Let me look for the laws. Both the incident ray and the reflected ray all lie on the same plane. They all lie on the same plane, and then the I is equal to R. But in refraction, we know that there is something that is called Snell's law. Okay, Snell's law. Okay, the Snell's law states that the ratio of sine of the angle of incident to the sine of the angle of reflection is a constant for any given pair of media. That is sine I incident first all over what? Sine R is equal to what? N. So therefore sine I is equal to what? N sine R. Okay, where N is a constant. Okay, where N is a constant. So you have to note that. So that is that. Let me check my time. Alright, so in our next video, we now talk about diffraction, interference, polarization of wave. Okay, so these are the three that we're going to talk about in our next video. Thank you very much for watching. Please like, share, and subscribe.